Okay. So for 2.6, so we saw the parabola, which is y equals x squared. That's a basic graph. So when you see, like the test will say, draw the following graph, find the intercepts and vertex. But it doesn't tell you it's a parabola. So you see the x squared and you know that that's what it is. And then the other one we did was the absolute value. We did that last class. And it's done very similarly, except you don't need to factor to find the intercepts. You just use what you know about absolute values. So the next three types are an x cubed. So if you see an x cubed in the equation, you say that's a cubic. And it looks like a half a parabola up. So see, this goes up. That's the same as the parabola. Half parabola up. And then the other part goes down. Half a parabola down. Okay, so when we find the vertex, that's that middle point. We're going to call it the vertex just to keep the same language the whole time. It's not really called the vertex in real life, but we're going to keep calling that important point that you need the vertex, where you start from. So we're going to do that today. And then the other two are a cube root, half a parabola on its side. You have to remember which direction these point as well. So when you see a cube root, you know it looks like this. The important point is that middle point. And the last one is a square root. And it's just half a parabola. It doesn't have anything else because you can't put negatives in a square root. You can't put a negative under, so the x can't be negative, and you can't get negative answers, so the y can't be negative. So it's just that little piece. Okay, so you need to memorize those, because as soon as you see them, you need to know what they are. And then in 2.7, we're going to do the fraction, the hyperbola. So we won't add it to this. Let's add it to the list, because you need to know it as a basic graph, but it has asymptotes along the x and y axis. And I put it in a separate section because we don't find a vertex for it. We find the x and y intercepts, and we draw those first, and then we draw the shape. So this one is in section 2.7. So it just has a section to itself, just because we don't really find the vertex and then the intercepts. Instead, we find the vertical and horizontal asymptotes and then the intercepts. So we do it a little bit different. Okay, so we did already x squared and the absolute value. So today we're going to do the cube root, the cube, and the square root, those three. So let's start with a all right. So to be helpful, here's the basic x cubed. What would happen if I stick a negative in front of that, do you think? It flips it. So this one will come down, and this will go up. Okay, so if you see a negative, anything that's up goes down. And it's almost like if you folded the paper and traced what you saw. So it's a mirror image reflected about the x-axis. Okay, that flips it down. Now, if we have it, the minus in the x cubed bracket, so if we had, for example, a minus x in here, that's the same as saying minus x cubed, because you can do minus times minus times minus is a minus, so these are the same. So that's the two possibilities. Okay, let's do a few graphs of that. All right, so we do the vertex the same way we did for the parabola. So the vertex would be what? It's what makes this 0, -1, and right here, -8. Okay, so that's our starting point. Where is the vertex on our graph? It's like right here. So you draw that point, and then you're going to draw a half parabola up and a half parabola down from that. So let's do our y-intercept. We let x equal 0. So 1 cubed is 1 times 1 times 1. So x is 0, and we found y is -7. And then our x-intercept, we let y equal 0. How would we solve for this? We didn't do this type yet, but it's not hard. Bring the h to the other side. And how do we get rid of a cube? What do we do to both sides? The cube root. So you do the cube root of both sides. That cancels, so we just get x plus 1 equals, the cube root of 8 is what? 2. So 2 minus 1. So what you do is you isolate the cube and then take the cube root of both sides. Can you take the cube root of a negative number? Yes, you can have a negative under odd roots, just not even roots. So a cube root of, say, -8 would be -2. Okay, so we can do that. We'll see that in the next example. But you can, when it's a square root, you won't be able to. But we didn't do it that way. We did factoring. So you don't. Do you remember when you do, like, if you were going to solve like x squared equals 4, do you remember in high school doing the square root of both sides, but you had to do plus or minus? And then half the people forget to put plus or minus. We avoided that by always factoring. You can do it, it's a technique, but I find too many people make a mistake. And so we do it with cubes. Take the cube root of both sides. We don't factor them to find them, but with the squared, we factor it to find the numbers. Okay, so we've got all our points. This is not flipped, so we know that the basic graph looks like that. And it's good to draw what you know the basic graph is going to look like before you start and put your points on, because if your points don't follow this, then you've probably done one of these calculations wrong. So you put your vertex on, -1, -8. And then our y-intercept is -7 here, our x-intercept is there. I'm going to write the points in after I draw it. So it's going to be, this is our vertex, so it's a half parabola up from there. That's our half a parabola up. We have nowhere to connect the down one to, and that's okay. It just looks the same on the other side. Don't try to make this in all one step like an S. You'll get it marked wrong. A lot of people will draw that point and then they'll go like this or something. Mine looks okay. They'll do this. That's what I see a lot, like they think it's like an S. And if that curves back along over top of itself like that, it's wrong, because it doesn't do that. It actually is like a parabola. It keeps going in that direction out wider and wider. Okay, it does not curve around itself. So this is wrong. Don't try to make it like an S. Half parabola up, half parabola down, and you'll have it drawn properly. This lighting on this is weird. Okay, so that would be the first question. I'll write these points in. I wonder if it's a chord. That's worse than that. Oh, did it go better? I think it worked. Oh dear. Oh, good. Okay. Okay, so here's the second one. So in this second one, I put the minus inside the bracket, and that actually flips it. So our basic graph x cubed is half parabola up, a half parabola down. Now this is going to be a minus x cubed, so it's going to be the reverse of that. Half parabola down, half parabola up. So this is what our graph is going to look like. That minus in front of the x in the bracket is going to do that. It's useful to know that, what it's going to look like, so that you have a goal in mind. So what's our vertex? It's what makes the inside of this 0. So 3. And then our y value here, 1. So there's our vertex. Y-intercept. So 3 cubed. 3 cubed? 27. That's really high on the graph, so I usually put like a little squiggly line saying it goes up higher. Sometimes you won't even draw that. So 0, 28. X-intercept. So what do we do here? Move the 1 over. To get rid of the cube, you do the cube root of both sides. That cancels that. So that we'll have 3 minus x equals cube root of negative 1. Negative 1. It's okay to have a negative. 1 times 1 times 1 is 1, so negative 1. The cube roots we know are what? 1. What's the cube root of 0? What's the next one we know? 8. 27. 64. And yeah, I know one more. But, okay. You don't need to know those. Usually it's going to be in these first few, right, for it to work. Or something in between, and then you'd have to take your guess, just like with the square root. Okay, so minus 1. Actually, let's bring the x over to the other side to be positive. Y is 0. And I brought the x over, and the 1 becomes a positive on that side. So 4, 0. Okay. Now, with our absolute value and with our square root, you didn't always have to have x-intercepts if it was up higher. What about this one? Is this graph always going to cross both axes? Yes. There's never anything that you can do that would be no solution. Okay? You can plug in any x and you can get any kind of values for y. So these will always have an x and y intercept. Now we have a lot of positive values here. So our vertex first, 3, 1. Now, if you were to sort of put your points in, because it's better to draw your graph and then make it look good so it doesn't look like a straight line. 0, 28 is where? Way up here. Way up here. Right? Remember what your basic graph looks like. It was flipped because of that minus x. So it would make sense that this would go up. And where's the other one? 4 is right here, close. So let's draw that one. This one You see I crossed, that's definitely not 28, but just write 0, 28 in here, and this is what I usually do. So if it's higher that you wouldn't be able to see, or the graph's up high, I don't have any tick marks on here. This one is 4, 0. I usually draw it, then put your intercepts in, make sure they look like they would be about right. If you've got a high number like 100 or something, you're not going to draw that way up here. And in fact, with the way that would have to curve to get all the way up to 28 before it crosses through, it's going to kind of look like a straight line, and then you'll get it marked wrong. Because these are not straight lines, they're like half parabolas. So you have to be careful that it looks curved. Okay, example 3. So what do we know about this one right off? It's flipped. So here's your regular x cubed. It's going to be the flipped one, so it's going to go this way. When I draw these, I have lots of experience, I always draw the basic graph really close to it so that when I go to draw my real graph, so don't skip that part. Draw what you think the basic graph is going to be and then find your points. Because then when you go to draw it on, it has to look like that shape. And remember, all these shapes are just like if it were a little piece of plastic that you made and you pick it up and you move it to the new spot. Right? So the shape is going to look like this, but it's going to be moved somewhere else. Okay? So what's the vertex? 3 is what makes that, and 0, right, because we don't have anything here. Y-intercept? Be careful with negative signs. We have -3 cubed. -3 cubed is -27. And we've got a negative outside, so it'll be positive 27. And now our x-intercept. What do you think? Maybe you don't like the minus outside of that bracket. So we could move that over here. Flip sides, -0 is still 0. So this is the same thing. Do you agree with that? I move that bracket over here to be plus, the 0 over here. Now what do we do to both sides? Cube root. These cancel. Cube root is 0 is 0. So 3 zeros. Does it make sense? This was already the vertex? Is where it crosses the axis, and that can happen, right? So, vertex first. 1, 2, 3, 0. And then the y-intercept is way up high on this axis. But remember, our graph is flipped, so does it make sense that it goes this way? Yes. I'm going to cross through. I'm just going to call that 0, 27. Whatever you do on that side, make it look similar on that side. Now, that's up pretty high. You could do a little squiggle if that makes you happier. Right? It says skip a bunch of numbers and put it there. Do we need another point to connect the other side to? No. They look the same on both sides. So you just draw one side and then just draw the other to look about as wide as the first side. Okay, that's cube root, or cube. So now we'll do cube roots. All right, so a cube root, the basic graph, same idea, it's just on its side. We're actually doing them the same way, except in a cube, when you're trying to solve here, you do the cube root of both sides. In a cube root, you're going to cube both sides, the third power instead of 1/3 power. It's 3 power. So it's just the opposite of this. And the shape looks the same. There's always an x and y intercept, just like the last one. So what if I put a negative in front? What's that going to look like? Like that. That will also be this one. If the negative is in front of the x inside the bracket, it's still like that. Okay. Vertex. What makes the inside of the bracket 0? Just 0. And here? 2. Y-intercept. That's always the easier one, so I've just been doing it first to get it out of the way. Plug in 0. Cube root of 0 plus 2 is 2. So the x-intercept same as you're solving the last one. You isolate that important part, that cube root. You're going to leave that by itself on one side and move the 2 over to the other side. So minus 2 equals the cube root of x. So now if we want to solve for x, what do we do to both sides? What's the opposite of a cube root? Cube both sides. So that's like this. These cancel, so that's just x equals negative 2 times negative 2 times negative 2. Negative 8. Vertex first. Now I always say, okay, what's my graph supposed to look like? So if you hadn't drawn it at this point, you say, okay, it's a regular x cubed, it's not flipped, so this is what it's going to look like. I need to draw half parabola up, half parabola down. Minus 8 is where it goes down, so that's like way out here, but it's hard to draw that curved part. So draw the parabola and then put your negative 8 in. You don't want it to look like a straight line, so it's best to just draw it in and then draw that one about having about the same curve, the one you did down. Okay, what I keep saying is this. If you put 0, 2 here, and then you say 2, 4, 6, 8 is way over here, this is very hard to draw it to look like a parabola and pass through this point that I wrote on here. If I do that, it's very hard to draw one that's stretched really far that looks curved the right way. Do you see that? Like I'm trying not to make it look straight. I don't, this definitely, it looks like I'm bumping up to get over to the 8. But what you want is that shape, like a half a parabola. It's better to draw that half parabola than put your intercept on. Right, because you need the shape to look right. If you had a computer, you could see it. It would be able to draw it more carefully than you. Even on graph paper. If one of them is really far out, it's really hard to make it look curved. Okay, and it can't look straight because it's not a straight line. This one curves down and that one curves up. Okay. So that's one, like a cube root. Now, we haven't seen one of these in a bit. Y equals the cube root of 2x plus 1 minus 1. So this is a little harder to just read the vertex off, because what do we need to do that's different? For our vertex, we have to say, where does 2x plus 1 equal 0? So negative 1/2, and then what's the y value? Negative 1. That's still what's here always, so it's just that inside. Sometimes it's not as easy to figure out what it is. Y-intercept. So 2 times 0 is 0 plus 1. Cube root of 1 is 1. So 0, 0. What does that mean? That's both the x and the y-intercept. If you solve the other one, you'll get that same point. You could do it if you wanted to, but there's not another point, because that's where it crosses. So you could say, oh, well, that's the x-intercept and the y-intercept. Or you could plug in y is 0 and solve it, and you would still get the same answer. All right, you could go through and solve. You should get x is 0. It would be good practice for you to try it anyway. You should get the same point. Okay, so if we draw this, write your vertex in. So minus 1/2 minus 1. It's down here somewhere. Is this one flipped, or is it the normal? It's the normal one, because where are you looking for the minus signs? In front, which it doesn't have, or in front of the x part inside the bracket, and neither of those are minus, so it's the regular one. And 0, 0 is our point, so this one is a half parabola up, and then you mirror image that one going down. And we don't need any other points to hook them onto. Okay. Questions? So you get that center point and do a parabola one way, and then a parabola the other way. Yeah. Yeah, because it goes through right here. That's both the x and the y. It doesn't cross through anywhere else. Okay, so one more of these. I'm doing 3 of each, so the third one, y equals 2 times the cube root of x plus 8 plus 4. Vertex. What makes the inside of that 0? Negative 8. And over here, 4. That 2 has nothing to do with the vertex. Okay, so you can have a number or a negative, anything out front, and that doesn't affect anything. Y-intercept. Zero plus 8. 2 times the cube root of 8. What's the cube root of 8? 2. 4 plus 4. X-intercept? So we need to isolate the cube root. So what do we move first? The 4. Now that's not isolated when there's something in front of it. What do we have to do with that 2? Divide both sides by 2 to get rid of that 2. Anything that's multiplied in front you would divide. So we would have negative 2, 4 over 2 is negative 2, equals the cube root of x plus 8. So how do you get rid of the cube root? Cube both sides. They cancel, so that's x plus 8 equals negative 2 cubed, negative 2 times negative 2 times negative 2, negative 8. I try to keep the numbers sort of small because if I did it 5 cubed, you'd have 125. And bring the 8 over. So x is minus 16. So what point do we start with? We've got 3 points here. Which one do we start with? Always the vertex, because your parabola is going to move from there. So negative 8, 4. Negative 8, 4. Now you say, okay, is this one going to be flipped or not flipped? That would be the second question you say. So you look up and you say, okay, it's the regular one, so that goes this way. My advice for on a test, if you're not good at memorizing things, is make sure you know them. Practice them without looking. You say, okay, I've got 6 basic graphs to memorize, and practice just writing them. And then when you get to the test, draw them on the back of your test. Whatever it is you need to memorize. If it's formulas or graphs, whatever it is you need to have memorized, write it on the back of your test before you start. Because then you've got a cheat sheet. Flip your test over. You don't need to then worry about remembering everything. You can just say, how do I do this question? And you've already got the stuff you need memorized. So you don't have to keep looking in your memory to get it. You can forget about it and flip your sheet over and look. So when we do trig and things like that, that's going to be very useful because you'll need to know all your trig identities. If you can memorize them enough to write them down all at once, then you've got them written down right on your test. Right? You'll be able to flip your test over and look at them. Okay, so this is our shape. So we're going to go half a parabola up from here. What's our point going to be? 8. So maybe here. And then this one is negative 16 way down here. I think that one would be harder to draw. But half parabola up, half parabola down. This obviously not 16, but I'll write it in. So I went here to be 0, 8. Okay. More important than your points being the right distance away is writing the points on the graph and having the shape look right. If the shape doesn't look right, you lose marks. That's what you lose marks for. The shape has to look right, and if you label your points and they sort of make sense, like you don't write positive 16 instead of negative, then it'll be okay. Okay, so the last type is the square root. So this one's a little different because the regular square root is only a half parabola on its side, like that. It doesn't always have an x and a y-intercept. Okay, it will have a y-intercept, for sure, has a y-intercept, but may not have an x-intercept because we can draw it so that it moves up here. Oh. So may not have either. There. May not have it there. May not have a y-intercept and may not have an x-intercept. So it just might have that point, that vertex, and then you just draw it. That's easy. If we put a negative in front, what happens? It flips down. Okay. Now, if I put a negative in here, it actually flips that way. How do you, so I've got it going in quadrant 1, this is quadrant 4, this is quadrant 2. How do I get it over here? What do you think? Negative in front and inside. So our real one was here, but that flips it this way and then down. So you can have all 4 of these possibilities. Usually you don't need to worry so much because you're going to find the intercept and you'll write it in, but you need to make sure it curves. How could we call this curve? So if you're thinking of a parabola opens this way. A square root is always on its side. It's either this part of the parabola, this part, so this is, or it goes this way. This one is negative and negative, negative. But it's always a parabola on its side, okay? So when you go to curve it, you need to sort of remember what the shape looks like so that you curve it the right way. So there's 4 possibilities for that. So if you remember which way they curve, or which way they curve always around the x, what's the vertex here? 0, because it's just a 0 inside the root would make it 0, and 1. Now what's the basic graph going to look like? If I draw that vertex, where does that vertex go? Up 1. And this doesn't have any negatives, so it's the normal one. Is it going to have an x or an x-intercept? No, and that is the y-intercept. We've already got it. I'm done. I don't even need to find anything there. Okay? All right, so this one we'll have to do something for it. So it does have a flip, and it's an inside flip. So if you look up above, the one with the inside goes this way. Okay, what's the vertex? Yes, to make this 0 is 4, and over here is negative 6. So let's just say this is 4, negative 6. So it's down here, and it's going in that direction. So is it going to cross the x and y axis? It might not cross right where I just drew it, but it will cross both because we're going in that direction. So when we go to find them, so the y-intercept, x equals 0. Square root of 4 is 2. I didn't draw it right, but there it is. X-intercept. So what do we do first? 6 over. Next, divide by 2. Now to solve a radical equation, we square both sides. That cancels, so we have 4 minus x equals 3 squared, 9. Let's bring the x over and the 9 that way. Now, when we're solving these radical equations, it's important to check your answer. Can we plug 5 into this radical and get a positive under it? 4 minus a minus 5, 9, positive 9, so it works, okay? If you know what the shape of your graph is, you'll know that that's an answer anyway, that you need an answer, but you'll still find an answer if it doesn't have one, so you have to check your answer. And we talked about that lots of times. When there's a radical, you always have to check your answer. Radicals, fractions, and logs are the 3 places you always have to check your answer. Okay, let's draw it. So our vertex first, 4 and negative 6. And then negative 5 is a little higher than that, and negative 2 is up here. So it's a half a parabola, and I can't draw it going through the points I did, because I want it to look like a half a parabola. We want it to be curved. So this would be the point, negative 5, 0. And this would be the point 0, negative 2. I'd probably redraw that. But oh yeah, so that's better. That looks a little better. I don't like that my negative 5 is that close. I'm going to try to draw it farther. Okay, so I didn't get my third one in of those, but you should just practice them anyway. Okay, so what we'll do next class is the fraction, so we add in asymptotes to them. But you can do this whole thing now, and we'll finish 2.7 next class.